so we've talked about rational expressions, and I wanted to take a look at what you might call a not quite rational expression. A more precise mathematical term would be algebraic expressions, because, like I said, they're not quite polynomials now. Instead of just your standard, arithmetic operations, we're also allowing a root to show up. So, just as an example here, let's take a look at this guy. All right. So, yeah, we got up top, that should be a minus. I wrote a plus. That would throw things off. So we have the square root of the quantity x plus 3 minus the square root of 3. The whole thing is over x. Now, you'll see why this is significant as we move on in the course, but for now, you may notice that this is a bad thing if x equals 0, because dividing by 0 is an undefined operation. It gets you a one-way ticket to math jail, and nobody wants to go to math jail. So we can't plug in a 0 here, for x, in the bottom. But you might notice if you tried plugging in 0 for x in the top of this thing, well, you end up getting a 0 again. And so you have like what you might call 0 over 0. Don't try doing that, but that's sort of what it looks like. And that's kind of an algebraic clue that there's something we can do to clean this up. And the trick we're going to use to clean this up is what you might hear referred to as rationalizing the numerator of this expression. So what we're going to do is find a clever thing we can multiply top and bottom by that it makes things worse before it makes things better. You may look at this initially and say, why is that going to help? Why are we doing this? I promise it'll make sense. Anyway, so here's what we're going to do. We're going to focus on this thing up here in the top, and we're going to rewrite it with exactly one change. So, see the change, right? Instead of a minus, I've got a plus here. So the square root of x plus 3 plus the square root of 3. Don't change the sign under the radical. Leave that one as it is. But again, whatever we do to one part of the fraction, we got to do to the other. So I got another copy of that down below. Now, you're looking at this and you may be saying that's even nastier than what we started with. Or is it? Because down below, I'll grant you, there's not much you can do with it. I generally recommend that students just don't mess with the bottom at all. Just like write x times this thing with the parentheses and stuff. Don't try to distribute the x, nothing like that. You'll see why in a moment. Now, if you look in at what's going on up top, this kind of looks like one thing minus another. I'm just going to call that a minus b. This second piece here, it's got the same a and the same b, but we've changed the symbol that's in the middle to a plus b. And at this point, there might be sort of like a bell that dings, and aha, yeah, that is the format for a difference of squares. We just get the square of the first guy minus the square of the second guy. Again, you can check by foiling this thing out. Stuff cancels. That's what you're left with. So we referenced this before with that x squared minus 4 in the previous video. So now, what's the square of this thing? Well, squaring a square root drops you back at what's underneath the radical. X plus 3. Minus, what's the square of this guy? Same deal, right? Squaring a square root, it just goes away. They see each other out of the Vance hole, and we're left with x plus 3 minus 3. And at this point, it starts cleaning up, and because plus 3 minus 3, bada bing, bada boom, we wouldn't normally, worry about those. Now, all we're left with up top is an x. Oh, look! There's just an x hovering around by itself at the bottom. Now, I'm always wary about trying to cancel these things out like all together because it looks kind of awkward, so I'm going to write this thing at the bottom. So it's not well written because it's at the bottom of the board. I'm trying to dodge the tray with my hands, but hopefully you can make sense of this. Now, these guys each go poof. What am I left with? When I cancel away everything in the numerator, it's not 0. That's right. I have a 1 because it's like a division multiplication thing. So So it turns out this thing chops down simply to 1 over the square root of x plus 3 plus the square root of 3. I mean, we can't combine those. Don't try to write it as the square root of x plus 6 or anything like that. You got to leave it as it is. But this has a big advantage over this, because if you look at this guy, we can plug x equals 0 into this fella just fine. I mean, it's kind of a weird looking, like 1 over 2 times the square root of 3, number, but we can plug in x equals 0. It's no longer giving us an undefined operation. And that's why this is going to end up coming into play with some of the examples that we're going to see as the semester rolls on. One example down, I wanted to take a look at a slightly more involved one before we draw this video to a close. Okay, so we've got this new guy here. He looks a little more involved. We don't just have an x down below now. We've got x plus 1. Up top, we have the square root of x plus 5, and we no longer have just an awkward radical hanging around on that 2, which is something that will often kind of trip people up when they see this. So same principle though. The bad x coordinate in this case is -1 because 0 denominator bad. If you plug -1 in up top, you're going to end up getting a 0 again. I leave that to you to check, but 0 over 0, there should be something that'll clean this up. So we'll try that same thing again. I have referred to this in the past as a square root conjugate of an expression like this. I'm not, that's not like 100% what everybody will call it. Some folks, will use different terms. I like that one for reasons that aren't worth getting into. Let's get back to the problem. All right, so now, same deal. We're not going to try to do anything fancy with the bottom. Please do not attempt to foil this. That's not the intent, and it's just going to make the waters even muddier. I know it can be hard, but let's just leave the bottom as it is. But again, up top, a minus b times a plus b. It's a difference of squares again. We've just got to be a little bit more careful with it. So squaring this guy does the same thing as before. The x plus 5, as you're saying, all we're left with is what's under the radical. The square and the square root, they crash into each other and explode like the Monday Night Football helmets used to. So x plus 5. This guy squared, and again, that's the important part. Remember, we have to square this thing, because, remember, that's the formula. A squared minus b squared. What's 2 squared? It's 4. That's what'll throw people off, because that first example kind of already had the radical baked into it, so you just kind of didn't write it. This time around, we don't have a square root, and if you don't remember to square this, the magic kind of ends up falling apart, because x plus 5 minus 4, that's x plus 1. That's x plus 1. Yeah, they both just bounce, like, right now. And it turns out, all we're left with is 1 over that guy right there, the square root of x plus 5 plus 2. So again, this thing, unlike our original example, we can plug x equals -1 into him just fine. This time around, it turns out, since you end up getting a perfect square, it's actually even cleaner than the last one. So rationalizing numerators, it's kind of it's a trick that we're going to end up seeing useful in a few different types of things that come along the pike in Calculus 1. So wanted to go ahead and mention it because it's something that you might not have done in a while, kick some rust off the bike chain, so to speak. All right, there's one last thing I want to discuss before we draw the curtain on pre-calculus review and then actually get to the calculus, that thing you signed up for.